And this week on Quality Digest Live, we'll chat with Ron Rode, chairperson of the Coordinate Metrology Society, about CMSC 2015.
Plus, the pathetic pathology of estimation. That and more when we come back. Welcome back to Quality Digest Live for April 24th, 2015. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest editor-in-chief, Dirk Ducharme. Well, carbon nanotubes are in the news. The folks at MIT, anyway, not surprisingly. But before we get to the newsy bit, for those of you who are not in the know, carbon nanotubes are really small tubular cylinders of carbon atoms that have really some pretty amazing properties. At the individual tube level, they have 200 times the strength and 5 times the elasticity of steel, 5 times the electrical conductivity, 15 times the thermal conductivity, and 1,000 times the current capacity of copper, that's huge, at almost half the density of aluminum, all this according to Nanocomp Technologies. And as the name implies, the diameter of a carbon nanotube ranges from 1 to 50 nanometers.
Really little.
Really little, a billionth of a meter. Well, aerospace engineers at MIT have now developed a carbon nanotube film that can heat and solidify a composite without the need for the massive ovens that are typically used, particularly in the aerospace industry. According to MIT, when connected to an electrical power source and wrapped over a multi-layer polymer composite, the heated film stimulates the polymer to solidify or cure. So they tested the film on a common carbon fiber material used in the aircraft components, and they found that the film created a composite as strong as that manufactured in conventional ovens while using only 1/100% of the energy. Now this is a big deal because currently, let's say, in the fuselage of an Airbus 350, for instance, it's cooked in an oven that's 4 stories tall, costs tens of millions of dollars, and uses a whole lot of energy. The MIT engineers say that the carbon nanotube film is incredibly lightweight. So after it is fused using this process to the underlying polymer layers, the film itself meshes with the composite, adding almost no weight to it. So in experiments, the engineers tested the film's ability to generate higher and higher temperatures. They want to know just how hot could the film get before self-destructing. And they found that it really topped out over 1,000 degrees Fahrenheit, well above the temperatures needed by typical high-temperature aerospace polymers. So basically what we're talking about something is kind of like a self-baking pizza. Imagine you had a pizza and you plugged it into the wall and it baked itself, and you unplugged it and you ate it.
That sounds great to me.
Isn't that awesome?
Right now, yeah.
Exactly. Well, that's the idea, is you wrap this film over the composite, and we're talking now not just the sample like you're seeing on the screen there, but maybe an entire airplane fuselage. You plug it in, it heats itself up, fuses the composite, and that's the end of it. There's no need for huge ovens, and a lot of technical things need to be dealt with, but that's kind of what they're talking about here. So really, really interesting thing. The team who worked on this, including MIT graduate students Jenyun Lee and Itai Stein and Seth Kessler of the Metis Design Corporation, they have published the results in the journal ACS Applied Materials and Interfaces. So if you're in the aerospace industry working on composites, interesting stuff. Could be something new coming down the line for you.
Yeah, it's amazing that the technological breakthroughs that we see now are so quickly reduced to practice, right? I mean, it's like there's, you know, this to me is not pure science. I mean, it is pure science, but it's science that has a very specific goal for industry.
Right.
And you know, I don't recall, I wasn't really very involved in industry, you know, a couple of decades ago. I don't really know if it always was that way. I don't know if it always was reduced to practice as quickly and as intentionally as it is now.
Well, that's interesting. Yeah, I mean, a lot of times you have scientific breakthroughs which are really just in order to set the foundation for stuff that's going to come on top of it, right? And so then you have stuff like this where you have carbon nanotubes, which have been around for a while, but now they're starting to work their way into practical applications as time goes by. So it's interesting stuff. So
yeah, and like I said, it seems like every day there's a very practical breakthrough that is getting into the space. So really interesting stuff. We like covering that stuff, so we'll be covering it for you going forward as well. All right, well, it's time again now for CMSC Corner, which is one of the newer segments on our show, and it's where we chat with members of the Coordinate Metrology Society about issues confronting portable 3D measurement professionals. Quality Digest, as many of you know, is the media sponsor of the annual Coordinate Metrology Systems Conference, and we'll be there covering the show in force this July from Hollywood, Florida.
July, Hollywood, Florida.
Yes, humid. Warm. You talked about self-baking ovens.
Let's talk about self-baking ovens.
There you go. Definitely. Well, the large volume, close tolerance hardware and software tools of Coordinate Metrology are invaluable, of course, to manufacturing sectors such as aerospace. We just talked about aerospace, automotive, medical device, telecommunications, and many more. The latest and greatest versions of this equipment, in addition to lots of intriguing white papers, are going to be on display there in Hollywood at CMSC 2015. In this segment of CMSC Corner, we're joined now by Ron Rode, who's the chairperson of the Coordinate Metrology Society's Executive Committee. Ron's day job is as the program manager for tooling and portable CMM services at Planet Tool and Engineering in O'Fallon, Missouri. So, Ron, welcome back to Quality Digest Live.
Good afternoon, Mike, Dirk. Good to chat with you guys again. And thank you for giving me a few minutes to chat a little bit about the upcoming conference. It's going to be as always, extremely exciting and educational.
Yeah, we look forward to talking to you about it. So let's start off by asking you a little bit more about the CMSC. So who actually attends the CMSC, for anyone out there who doesn't know, and why do they come to the show?
Those that attend, anybody who has any kind of need or works in as an occupation of metrology, and I'm mostly referring to the portable industry, where you take your CMM and you go out into the world with it. Those are the people that are there. The shop floor user, those in academia, those looking to just get information. But CMSC is all about education. Our charter is transfer of technology. And this is one place where you can go and in one room see almost all of the latest cutting edge equipment that is out there on the market, along with softwares and the peripherals.
Well, let's talk about that, because what you referred to there really is the exhibition hall, and it's always, for me, a highlight of the annual show. We love walking around and seeing all the latest and greatest stuff and how it changes from year to year. So it features, as you mentioned, not only the top hardware and software and peripherals in the industry, but the always popular measurement zone as well. So what in particular can we look forward to seeing in the hall and from the measurement zone this year?
Okay. Well, in the hall, as in the past, the OEMs bring out the latest and greatest. This is kind of a rollout for a lot of them. So what is new, what's coming out with laser trackers, articulated arms, photogrammetry, videogrammetry, laser radar, all these different sensors and machines, you're going to see all of that. You're going to see the latest and greatest of the software that goes along with it, the aids, the targeting, things like that. The measurement zone, which has grown from one little 2-foot by 8-foot table several years ago, now will encompass over 2,400 square feet. There's going to be 5 different zones. We've got e-learning going on in one. We've got competitions. So if you really think you know how to operate these systems, come on out and prove it to us. We've got areas where there's going to be education. These different systems are going to be set up with parts to measure. We're going to have motorcycle fairings. We're going to have various other true real-life objects that you will actually be able to take these systems and play with them, learn how to use them, get your information from that. So the measurement zone is going to be quite the area again this year. That's one area you do not want to miss.
Let's kind of springboarding off that. A few weeks ago, we spoke with Randy Groover about the CMSC certification program, which really just continues to grow in importance. From your perspective, what are the benefits of certification and for individual metrologists and for the industry as a whole?
For the individual, certification is it's kind of like an ISO statement. You have the knowledge, you have the background, you have the expertise and the experience. You're not just going to get your info out of a book. You walk the talk. You have done over the years what it takes to become someone that can be trusted in the field, to acquire properly and then supply you with data that is accurate and reliable. And a lot of this data is making multi-billion-dollar decisions. And so you want somebody that, one, knows what they're doing and can do it properly, accurately, and on time for you. So what does it mean to the industry? Those that have it, if I'm going to go out and look for someone to do a particular project for me, then that's the person I'm looking for. Because I know that once they've been certified CMS, and it is a true certification, that they can do what they say and say what they do.
And I should say the measurement, if I remember right, the measurement zone that we were just talking about, that actually gives, is a place where attendees can actually test whether they actually have their skills, right? I mean, isn't there kind of a little thing where they can go in and participate in some studies and actually find out whether they're as smart as they think they are when it comes to metrology and hands-on?
Yes, that is true. So there will be an area there where, you know, they'll be able to just kind of test themselves and see if they're actually ready to take the next step and apply for the certification exam.
Okay.
Well, you know, Ron, the CMSC always has, and we've seen this being at the show now for over a decade, always has really great, interesting, engaging keynote speakers. This year, the keynote speaker is inspirational too. So what can you tell us about our viewers as well, about this year's keynoter, Dana Bowman?
Dana Bowman is quite the individual. He is a ex-Golden Knights parachutist, Special Forces. He, during an exhibition, collided in air with a partner. That incident left him a double amputee. From that, he has taken what most would be considered a disability for life, and as he likes to describe it, it is now his ability. He has worked actually very closely with a lot of the 3D metrology people and OEMs in developing all these different artificial limbs and things, not only for himself, but for those in need. Dana will be recapping his story, telling us how the things are, and it leaves you with an extremely positive feeling toward life. So if you ever thought you really had a bad day, once you've seen his story, it makes you feel good.
Well, Ron, thanks for joining us here on the show this morning. I should mention, by the way, because we didn't touch on it, the CMSC show really, we've said this a jillion times, really is probably unlike any other trade show you've been to, and mostly because of it's a very collegial feel there. I mean, yeah, there's people there with booths and they got their products, but you don't get this sense of competitiveness and so forth. It really is a lot about knowledge sharing and really understanding how all this fantastic equipment that you'll see on the exhibition floor, how that really can be used in real life examples. So it's a great show. If you're involved in portable 3D metrology at all, it really is a show you have to go to.
Right. This is one area where you can stand in one room and basically see it all, and the networking is invaluable. The people that you can actually interact with as far as using the equipment and seeing, and if you have a question and if it cannot be answered there probably is not an answer yet. So it's a place for an invaluable education.
Well, Ron, we're looking forward to it. It's going to be a great show again. Inspirational keynoter Dana Bowman, of course, the exhibit hall, the measurement zone, a lot of great white papers. We hardly even talked about that.
Right.
Fantastic white papers. So if you're in this space, be sure to check it out. Visit www.cmsc.org to find out more information. So, Ron Rode, thank you again for joining us today. We'll see you down the road.
Very good. Thank you, gentlemen. Have a great afternoon.
Thanks, guys.
Okay, so long.
Bye-bye.
Okay, well, we had a very interesting, somewhat tongue-in-cheek article by Jim Benson this week. Our five estimate pathologies, got to say that just right, which points out the whole problem with estimates. Mainly the problem is that we believe estimates are cast in stone, even though we are told they are, estimates, right? It's an estimate. And worse, when we make an estimate, we believe we are right and that our estimate is cast in stone, even as, the walls fall down around us. So there are 5 pathologies here, says Benson, and I would also add that there is some inventive word creation going on by Benson. The first pathology is guarantism. That's the belief an estimate is actually correct. We're all guilty of this. Someone gives you an estimate, let's say you have, a plumber or your auto mechanic or whatever, and you view it as an absolute. You get an estimate on having your car repaired, and the mechanic takes a look at the problem and gives you a repair estimate of $650. He starts working on the problem and finds that the problem is worse than he thought. So he calls you and he says, look, we also have to replace the flux capacitor. So it's going to cost you $825. And we're shocked. We're shocked. Shocked, I'm telling you, that the estimate was wrong. How in the world can an estimate be so far off?
I'm shocked that a flux capacitor is only $825.
I know. Well, they've come down since the days of the DeLorean.
I got to get my DeLorean out. Yeah.
Exactly.
Wow.
And of course, we try to, hold the repair guide to that initial estimate. So guarantism, dollars, dates, and milestones become truths the moment they are uttered.
That's true.
Well, it's kind of silly, right?
Yeah,
okay, the second pathology is promissoriality.
These are great words.
Promissoriality, that's right. That's the belief that estimates are possible. This is the flip side of guarantism. This has to do when we make an estimate. When we give an estimate, says Benson, we feel we've given someone our word. We feel like it's a promise. That means we take ownership of it and become entrenched in this estimate that we've given, even though it's an estimate, right? We believe our own estimate and begin to ignore warning signs that the estimate may in fact have been only, guess what? A guess.
Uneducated
Maybe
guess.
an educated guess, but a guess just the same. And in some ways, this is in response to our desire not to be one of those repairmen whose estimates always seem to be lower than what the actual repair bill will be. We don't want to be that guy, right? So we believe our estimate. It has to be right because I'm not like that other guy. The third pathology, Swamyitis. Swamyitis, that's the belief that an estimate is the basis for sound decision making. So building on the second pathology where our estimate must be right, we start making plans and decisions based on those estimates. And further, says Benson, we believe that the actions included in our plan will result in the product that we envision, and that each product we envision will have an effect on the market. So the larger the project, the more guesses upon which we base our work, and so we build our plans upon guesses and assumptions and, completely forget entirely that we're building on guesses and assumptions. And when you build on guesses and assumptions, it's like building your house on quicksand, right? It sounds pretty good until you start building, and all of a sudden things start falling apart. Okay, the fourth pathology of estimates, craftosis. This is the assumption that estimates can be done even better. We believe that estimation is a skill, says Benson, and that we'll get better at our estimates. And true, the more you do it, the better your estimates become. Estimate skills can be honed, but our accuracies, you got to remember, are always affected by variation in the work. And high margin work usually includes high variation. This variation is bad enough if you look at it at the project level. But when we plan or estimate it at the task level, and we talked about this last week, when you look at something at the task level, the role of variation is so severe, says Benson, that simple changes in the weather or the absence of a colleague due to the flu can derail an estimate and an entire project. And finally, the fifth pathology is reality blindness. This is the insistence that estimates are implementable in business. We create estimates and plans and begin work immediately, rarely with the expectation that those plans will change. Benson contrasts this kind of what we do in business with a much more realistic form of estimating where change is expected and planned for. And he uses as an example, let's say, civil engineering, where he explains that there are different levels of estimates. There's a planning level estimate, which is an estimate believed to have a high degree of unknowns. and it's subject to a lot of variation and uncertainty. There's an engineering level estimate, which actually comes with gradations of certainty, and then there are construction plans which will be provided and reviewed for 20%, 30%, and up to what's called a 100% submittal. Now this is in civil engineering. The 100% submittal is when work can actually begin, when actual construction designs are then further refined as you go along. When the project is completed, a whole new set of drawings and documents are created to document what was actually built, and these are called the as-builts. This is because even in a theoretically so lower variation environment like civil engineering, not a lot of variation in civil engineering because things are fairly concrete, so to speak. Right. We still, even in that industry, don't build to our estimates. So can you imagine when you're trying to do estimates in a business environment, not something that is nuts and bolts as civil engineering, imagine the amount of variation is there, and to kind of count on your estimates being the base rock now upon which you're going to build everything just doesn't make sense.
Yeah, and that's the problem, is that each step builds on the one that comes before it. That's just the way that engineering generally works. You know this very well. And any one piece of that puzzle that isn't rock solid, and the problem isn't that it's not necessarily rock solid. The problem is people don't acknowledge that it's not rock solid.
Right, that's
people
the whole problem. Yeah.
It is rock solid.
Yeah, it's rock solid.
Well, maybe it is. If people would acknowledge more, and maybe this is what Benson is saying, is kind of own up a little bit more to the estimation game and say, hey, these are estimations, and we think they're pretty good, but we're going to know further as we go along.
And we'll adapt as we go.
We'll adapt as we go.
Not try to hold to it now.
Right,
yeah.
Probably a better way of doing it.
And
I think Benson's saying it's definitely a better way of doing it. So Jim's been rolling out some good articles lately. We've been
very practical stuff.
Very practical stuff. So if you're, he talks about Kanban a lot too, but this one really didn't deal with the Kanban aspect of quality improvement. So check out Jim Benson. As always, type in content by Jim Benson in our search bar in our homepage, and you can find all of Jim's articles that he's written for us right there. Another one of our columnists that we like very much is Davis Balistracci. You can do the same thing for Davis. Just type in Davis Balistracci, content by Davis Balistracci in our search bar, and you can find all of his stuff. Well, his latest article was one that resonates with me, of course, called Baseball.
Mr. Baseball.
Appeared in Thursday's issue, yesterday's issue.
How's your fantasy league going?
It's doing okay. It's not doing as well as my New York Mets, though. The Mets are in best team in baseball right now. Well, Davis is a baseball fan, as we can tell from reading him. And every year around this time, he comes out with a baseball-themed article here in April talking about it. Because, Davis, of course, is a statistician and a quality improvement specialist. And baseball is probably, of all the professional sports, of all the sports in general, is probably the one that most is built upon a foundation of statistics. But as we found out from Jim Benson, sometimes that base that we think is solid really isn't. And that's kind of actually what Davis is talking about here in this piece. This particular one focuses on umpires and whether they're right or wrong. Now, most fans, myself included, and maybe Davis included, would say, umpires stink.
They're always wrong.
Who likes an umpire? They're always wrong. They always make the call against their home team. Well, in actuality, though, if you look at umpires, they're actually highly skilled professionals, very well trained. Most umpires have been doing this for decades by the time they get to the major leagues. They're just as dedicated, just as good at their craft as the guys on the field doing their craft. But nobody's perfect. And Major League Baseball is now using something called PitchFX, which is a technology that helps to review the accuracy of umpires in calling balls and strikes. If you've been to a ballpark recently, you'll see that after every pitch, somewhere on the scoreboard it says how fast the pitch was and what type of pitch it was, fastball, slider, curve, whatever. PitchFX technology is what allows them to do this. They use cameras and they use computers to analyze the pitches, and it gives a lot of precision as to where the ball actually was when crossing the plate, as opposed to maybe where the umpire called it. So using that as a basis, Davis references an article that provides a lot of this data about balls and strikes and what were balls and what were strikes, according to PitchFX and according to what the umpires actually called. Well, according to a handy assessment by the author of that article that Davis references, 15% of pitches were called wrong.
15?
15%. 15% of pitches were either called balls when they were strikes or called strikes when they were balls, according to PitchFX. And that's just too high, as the author of that piece says. Well, the trouble starts right there, as Davis will always jump on something like that. It starts right there with an arbitrary figure of 15%, which just seems to be too much. Never mind whether or not the process of umpires calling balls and strikes may be, as Davis often says, perfectly designed to get that very result. Nope, in the opinion of this article, this author, 15% is too high. So the author takes a lot of time looking at the data to find out who was above and who was below that number. Who is wrong more than 15%, who's right less than 15%, right?
The umpires.
The umpires,
yeah,
right?
Yeah, okay, yeah.
So what Davis did is he does what he is wont to do always. He plotted the data on a scatter plot, right? Makes a lot of sense. I mean, just kind of run the dots, right? Run the data, as Data always says you need to do. And guess what? Minus one outlier, and there was one crazy outlier in this data, but minus one outlier, the data was indistinguishable.
Yeah.
In other words, there is no good ump, there is no bad ump below or above that arbitrary 15% error rate, which just seems to be too much in the opinion of that author of that article. So really what we're talking about here is there's no special cause. There's a common cause variation here going on with a 15% error rate. It's baked in some way to the process of umpires, human beings leaning over a catcher and in real time calling a 95-mile-an-hour pitch, either a strike or a ball, right? There's a 15% error rate apparently baked into that, and slight variations within that don't mean anything. It's noise, right? It means nothing at all. And rankings of who's good and who's bad don't help. I mean, surprise of all surprises. Given a set of numbers, as Davis says, half are going to be above average, half are going to be below average, 10% are going to be the top 10%, and another 10% are going to be the bottom 10%.
It's amazing how
It's
that works.
amazing how that works out, right? I mean, well, to any of you out there, I'm sure, who are doing industrial statistics or dealing with stats in your work environment, analysis like these happen all the time in industry, right? I mean, there's a process that's going on, and there's results, and there's numbers that come through, and people want to rank it. They want to figure out what's going on. But really what this points to is a basic lack of understanding about the nature of variation in work and in society. And that causes chaos and confusion, I think, whether it's in the assembly line, on the ball field, or anywhere else. I mean, people don't understand what variation really is. That's what Davis talks about all the time.
Right.
Is that people don't understand what variation is. They make assumptions, they make changes, which is the big problem. They make changes in this based on what they think the numbers are telling them, when it's really just normal variation in a process. 15% in this case, which is a good example, is apparently baked into the process of calling balls and strikes by human beings. And just because somebody is at 16% and somebody else is at 14% doesn't mean anything.
Right.
It's noise. It doesn't mean anything, but it's apparently, from this author of this article that Davis references, this guy wants to take some action, wants to say, hey, we've got to, penalize these guys for pulling a red bead, calling too many strikes, right? I mean, isn't that what it really is all about?
Yeah.
So, this is a really good example that Davis uses here. It brings it home to me as a baseball fan, and many of you maybe are baseball fans too, but we're also working in quality assurance. And if you're in this situation, show your bosses maybe this article and say, let's not draw conclusions so quickly. Let's look at this and think about whether or not it's.
And I think you need to do a field trip out to a ball game and actually observe this, in person.
Yes, that's right.
Just
with a beer.
With a beer.
With a beer.
I mean, you got to study it in its natural environment.
That's right. That's right. It's very important. It's a Gemba walk.
It's a Gemba walk.
It's a Gemba walk with beer. So that's
take a Gemba walk out to the ball field.
Very important to do that. So thanks for that, Davis.
All right. Well, before we go, I want to share with you this week's tweet of the week. And this one is, I like this one. The best thing about social media is putting up quotes and totally making up the source.
Yes.
And that came from Twitter user Susan Dolan.
Well, as Abraham Lincoln said, don't believe everything you read on the internet.
Yes, he did. He was way ahead of his time.
So, so there you go. Think about that. Well, thanks, Derek. Thank you, Twitter user Susan Dolan. Of course, you can always find us on Twitter, Quality Digest, for all those great tweets that we love bringing to you.
Oh, and by the way, we are also, we rolled out our mobile app.
Oh, we did, yes.
Just in time for Google.
Thank you, Google.
For those of you who don't know what was going on with that, never mind.
We actually referenced it on the show last week or the week before. We talked about this, that we're in this.
So Google, just for those of you who aren't in the know, Google was basically going to start penalizing websites that did not have a mobile-friendly, did not have a mobile-friendly site. So just in time for Google to not penalize us, we've rolled out our mobile site. It works awesome, looks awesome. Most of the stuff that you get on the desktop site is still available also on the mobile site. So if you are on a mobile site and you go out to www.qualitydigest.com on your tablet or smartphone or whatever, you will be redirected automatically to the mobile site. And you'll have all of the same news and content, but in easier to read format.
So let us know what you think. Check it out. Again, get your device out. Check us out at qualitydigest.com and let us know what you think.
There you go.
All right. Well, thanks, Dirk, and thank you all for joining us. Thank you, Ron Rode of the CMSC and Planet Tool for joining us as well. That's our show. You guys all have a great weekend. We'll see you back here on Monday for another great week of QDD, and back here Friday, of course, for another great Quality Digest Live.
So long.
See you then. Bye.
Four, three, two, one, fire.